Now we are going to see the demonstration of the example 2 and 3 together using MATLAB. Now I am sharing the screen. One second. So now I am sharing the screen. So we have discussed the example number 2 such that we need a panel requirement of 100 watt, right? With the current of a 20 ampere charge controller for feeding the load 12 volt 12 watt and battery ampere of 50 ampere hour, right? Then if you see the market available panel specification as discussed in problem 1, example 1, we have to take the user defined model and we have to feed these parameters to get our panel requirement, market available panel requirement, right? So for emulating this voltage by using the standard equation P equal to V square by R, will be calculating 12 ohm, right? So here also we need 12 volt, but here operating voltage is 20 volt. So we have to go for the buck regulator as the charge controller, right? Now we will be seeing the same simulation I have copied. Here the user defined, I have put the panel specification given in this table here, so that it automatically calculated 100 volt, 36 cells in series, open circuit voltage, short circuit current, maximum power point voltage and current, I feed it, right? We will check the panel characteristics at the standard conditions here. So plot it here. You can check it here. We'll be getting 100 watt as peak under the standard conditions. Okay. Now we'll close this block. We again open the MATLAB file. So buck regulator, I redesign. I think this design will work out for this load. So I keep it the same design. PI control little bit I fine tune, right? Then battery ampere hour. What is battery ampere hour here? 50 ampere hour. So here I just put 50 ampere hour here. Right, load I have changed to 12 from 24 from the previous problem, right? So for the first 0.15 seconds, source will feed load as well as charge the battery. After 0.15 to 16 seconds, I purposely disconnect both the sources. Then after 0.16, battery only will feed the load, right? Accordingly, I give the signal builder. Here you can check it out. So this is the signal which connect source buck converter to the load and the battery. After that, it will be disconnected. So this is the signal builder. Where battery is connected. For small time, it is disconnected. After that, it is connected. During this period, both source and the battery is disconnected to the load. Right? I'll run this file. So it is 12 watt load requirement, 12 into 1, 12 watts will be getting. We'll check it this output voltage scope here. So from this to this, the source is feeding the load and charging the battery. This period, both the source and the battery is disconnected. From this, only battery is feeding the load. We'll check the current. Put the auto scale. Can check the current will be around 1 ampere. 1 into 12, 12 watts we can have as the screen. So we'll be just getting the second problem simulated. Okay. Next, we are going with this third example problem. This we discuss now. Here, as per the calculation, we need around 300 watt panel. So we have to connect 3 panels in parallel. As we discussed, 3 panels in parallel, right? Each rated at 100 watt and we require 12 volt. right? We are using the same specification as in this. Here 20 volt will be there as they are connected in parallel. Voltage will not change. So 3 into 100, 300 watt, but 20 volt remains the same. Current will be multiplied 15 ampere. 3 into 5, 15 ampere. Okay. So here also we need to step down the voltage to get to the 12 volt load. Okay. So inverter rating 450 ampere hour. For this, I'm not taking inverter into account. Only I'm feeding the load directly because I'm not taking the inverters. I'll calculate DC load, which is equivalent to the AC load. Because inverter and modeling other things, it is out of scope of this lecture. So I'm directly feeding load from here. So we'll check it here. Here the panel, the same panel I have taken, but I put 3 in parallel, 1 in series with the same user defined function. Previous problem we have used the same thing I have copied, but I put instead of 1 cross 1, I put 3 cross 1. Okay. I'll check the characteristics. We can check it is 300 watt. Okay. Now I'm changing the load as 0.48. Why I'm putting for 0.48? For emulating this characteristics for simulation purpose. We need to calculate using this formula for the same problem. 12 volt divided by 12 square divided by wattage 300 watt. Maybe it is not typed here. So it is 0.48 ohms, right? The same panel specification we have used. Here 3 panels are connected in parallel with 12 volt and 5 ampere, right? So the same thing is here. That's why I put 0.48 ohms here, right? Similarly, for first 0.15 second, source is feeding load as well as charging the battery. For 0.15 to 0.16, there is no source to the load. After that, only battery feeding the load. I'll run this. Here PI controller I fine-tuned depending on the problem. And similarly, inside I have changed the inductor and capacitor values based on the design equations. Okay, we will check it this voltage scope. Check it here. It is there. Right, then current scope. You can check it here. It is around 25 amperes. So for any problem, even you can extend the scope to running the full time period, whatever we are mentioning as the battery extension time. So we can see the battery charging and discharging characteristics. Due to the time constraint, I'm not running the simulation for the whole time. If you are running for the whole time, we can observe the characteristic charging and discharging of the battery. Okay. Here you may not get to the discharging characteristics because we are not giving time to discharge time, right? So we may not get to this. We can open the scope. That's why I'm not opening that scopes here. Okay. Here only it will take time to discharge. This is state of charge. I'll put a zoom arc. First, the yellow color will be state of charge. Next one will be voltage. Next one will be current. You can check it here. Actually, it has to be fully charged. Then, as time goes on, it will discharge. The voltage will discharge. If you are running for the whole time, it will be shown this voltage. But as we are not running based on the battery specs, we may not know. This after this period, sometime it will be start discharging. This voltage will become decay, right? That we are not doing. If you are running the simulation time based on your battery, you may get it done. So for any problem, you can use simulation. After that, you can put inverter, any multi-level inverters with proper modulation. You can extend the load and it can definitely get the output. If it is a research purpose, we have to definitely take care of the battery charging and discharging time, you have to run for a full time and we have to do it out. So I'll just stop share. Hope this will be clear.